Okay, welcome everyone. This is the week 8 webinar of the class. So we're seeing the light at the end of the tunnel a little bit. Still have a while, but at least we're doing pretty well. And as always, I will start with any questions that you have. I'm always happy to answer them. And then, as we go, keep asking questions. And then we're moving into chapter 10. And if you remember last week, chapter 9, we talked about hypothesis tests. And I mentioned that was like the most important thing of the class because that's all we're going to be doing for the rest of the quarter. So we're almost all. So now we're going to continue in a hypothesis test. If you remember last week, we looked at a hypothesis test for a mean or a proportion. And that was decide whether this population mean is greater than this number, or the population proportion is greater than this percent. Now what we're doing is something actually much more commonly used, and that is a hypothesis test for the difference between means and proportions. And in particular, we're going to be comparing, and we're going to say, well, which is bigger, this group or this group? Or today or tomorrow when someone did something, what is bigger or what is different, what's smaller, that kind of thing. And we're going to be doing both hypothesis test and confidence intervals because you can do them both. That's the good news. So there's going to be 3 types. The first is going to be hypothesis test and confidence interval for the difference between 2 proportions. So if we have the proportion, of men who do something versus women who do something, and you want to see, is there a difference? You can find out. Okay, and you can run a hypothesis test. Okay, lots of different hypothesis tests, or online students, percent pass versus face-to-face students percent pass. And you can do a hypothesis test to see which, maybe online students do better. I don't know. And you can do that, and you can say how much better. That'd be more of a confidence interval. Okay, then we'll talk about hypothesis tests and confidence intervals for 2 means when they're independent. And that's going to be, first thing, the survey question or questions will be quantitative. So otherwise you can't talk about means. So they'll be quantitative. And then you're going to have 2 groups at which they're just this group and this group, not the first person with the first person, second person with the second person, third person with the third person kind of thing. And that's going to make them independent. Then we'll look at a hypothesis test and confidence intervals for a difference between 2 means when they're dependent. And again, still quantitative. And we're going to be having possibly 2 groups, but then the 2 groups are going to be kind of paired up. Or maybe one group when you're asking every person 2 questions that are quantitative and to see if there's a difference between the answers of the questions, that kind of thing. And then we started out talking about Project 2 last time, but now we're ready to go into the details because Project 2 is going to be really all about Chapter 10. And that's where we are now, is Chapter 10. So we'll have a discussion on Project 2. So that is the main things to talk about. Just want to remind you again, this is week 8. Why is that an important number? I've asked you this every other week, basically. Yeah. 8 is an even number, and even numbers are exam weeks. So there is an exam this week, so make sure that you get ready for it. And as we go through, hopefully you're seeing the pattern. Around half or so of the questions are going to be the stuff that happened weeks 1 through 6, and the other half will be week 7 and week 8. So it's more focused on week 7 and week 8 than it is on weeks 1 through week 6, but any question is fair game, is how I set up these exams. So make sure that you set up and get enough time to get those going. I don't recommend waiting until the last minute because I don't know, bad stuff could happen. You never know. You could lose internet, and that would be bad. So it's always better to do a little bit ahead of time. So are there any questions about anything? Any questions? Okay, if there aren't any questions, I'm going to go over chapter 10, and I like to do it by example because the theory is, I don't know, it's not that, it doesn't help that much in learning. So let's go to an example. And I actually read this today. That's the nice thing, is I can just go online and read about it for whatever's going on or whatever the newest sample was. And there was a poll done, and it was Gallup poll, by the way. And the question was, has satisfaction with the way things are going in the US increased from last year to this year? Okay, so what they did is they did a survey last year, and they did a survey this year. Okay, do they know the proportion of all Americans who are satisfied this year? Do they know that? Yeah, no. How do we know they don't? How do you know they don't know that? Yep, they didn't ask me either. Yeah, they didn't. My guess is they didn't ask any. You've never had someone say yes to the. Did they say they asked me? But they probably didn't. Okay, you can't ask every American. There's too many of us. So instead, what they did is they surveyed 1,013 Americans this year by telephone, and 1,011 last year. We want to use a 5% level of significance, and hopefully, after last week, you understand what that means. And in their survey, 19% this year said that they're satisfied with the way things are going. And 16% last year said they are satisfied with the way things are going. So, by the way, has the proportion of all Americans who think that, who are satisfied with the way things are going, has it increased from last year to this year? What do you think? What can you say? Okay, so the answer is you can't answer that question. We don't know whether the proportion of all Americans who are satisfied with the way things are going has increased, because we only have a sample. But what we can do is we can run a hypothesis test, and we can say, not that we know for sure that this year is better than last year, but maybe we can say we have statistically significant evidence. We'll find out, or maybe we can't, because 19% is not that much more than 16%. Is it enough more? Does that make sense? So we cannot answer the question for all Americans, but what we can do is we can determine whether you have statistically significant evidence. So what we're going to now do is do H0 and H1. So first thing, is this means or is this proportions? Yeah, this is proportions, because the survey question is, are you satisfied with the way things are going in the United States? And maybe put in the chat box, are you satisfied with the way things are going in the United States? You should all be able to answer that. Okay, so the important thing is I'm looking at the chat box and I don't see any numbers. This is not a quantitative survey question. If it's not a quantitative survey question, if this is a yes, no, what letter do we use? Yeah, P. But now we're in chapter 10. So we're going to start with P. But really, we're doing a comparison study this year versus last year. So I'm going to go P, then I'm going to do subscript 2023. That's this year. And then equals P subscript 2022. Okay, so notice that unlike chapter 9, the right-hand side was a number. Now the right hand and the left hand and the right hand are both variables. Any questions on this? They're both population proportions, which we don't know. We don't have a number for either. Okay, then we have H1. And the key here on this one is we can write P sub 2023. That's plus P sub 2023. And then what inequality is next? Is it less than, greater than, or not equal to? Yeah, it's greater than because the key word here is increased. If it increased, then 2023 is higher than 2022. So in terms of the proportion. So that means greater than P sub 2022. Any questions on that? All right. So now what we're going to do is we're going to find the p-value. And hopefully you're used to this. How do you think we're going to find the p-value? What are we going to do? Yeah, we're going to go to the calculator. And you're used to this. I'm going to ask you which calculator to use. Which calculator do we want to use on this one or need to use? Yeah, this is 19. We're now in two proportions because we have the proportion for 2022 and the proportion for 2023. Any questions on that? So this is going to be a two proportion calculator. All right, so now we have a first and second sample. The first sample, by the way, was the 2023. That's this year. That's 1013 for the sample size. The second sample size was 1,011. For the number of successes, well, for the 2023 year, the first one, we need to do a little calculation. And remember, 19% said they were satisfied. So we're going to take 19% of 1,013. So 1013 times 0.19. And it gives you, I'm going to round to the nearest whole number. That's 192. And for the second sample, 2022, that was 16% of 1,011. So 1,011 times 0.16. And that is 162. Any questions on that? Okay, it asks less than, greater than, not equal to. Our hypothesis had a greater than. Let's use a 95% confidence level, 0.95, and hit calculate. And just a note, a few notes. One is that when you're looking at sample sizes to make sure that this is reasonable, we have to make sure NP and NQ are both bigger than 5 for both groups. So notice NP is 192 for the first group. NQ is going to be 1,013 minus 192. Both of those are much bigger than 5. And similarly, NP for the second group will be 162. And Q is 1,011 minus 162. Both of those are much bigger than 5. So that means this normal distribution is the right way to go. And this calculator works. Otherwise, the calculator doesn't work. Any questions on that? All right. By the way, normal distribution, we use Z for that. There's a Z, it's kind of like a Z-score, 1.73 or so. Okay. The P is equal to 0.04. Okay, approximately. So let's write that out. The p-value is 0.04. When the p-value is 0.04 and we have a 5% level of significance, what does that tell us? Oh, what does a Z mean? So Z is like the Z score in the normal distribution for the difference between the means. Right? It's a little more complicated than I'm saying, but I can't get into all the math. So that's what the Z is. Hopefully that answers your question. Okay, so what is the conclusion for this hypothesis test? At least the start of it, if you don't want to write the whole thing. Yeah, there is a little more than evidence. There is statistically significant evidence to support the claim and then basically you just read H1 and write it in words that the population, what calculator do we use? So yeah, it was 19, and in particular, it was two proportions. That's the main thing, is the words are more important than the number. Two proportions, because we're looking at hypothesis test and confidence interval for two proportions. So there is statistically significant evidence to support the claim that the population proportion of all Americans this year who are satisfied with the way things are going in the US is greater than and let's just copy and paste. Greater than the population proportion of, I think I did all too many times, of all Americans last year, who, I guess it should be were, since it was last year, were satisfied with the way things were going in the US. Any questions on the conclusion? I do want to highlight population. If you do not refer to the population, you could say that the percent of all Americans this year, that's fine too, but you could have that word all or the word population. So you have to directly refer to it. Otherwise, I take off points. Any questions on the conclusion? Okay, let's interpret the p-value. It's very similar to what we did last week. And that, if you remember, the interpretation of the p-value in general was that if the null hypothesis is true, and we did the similar study, then the p-value is a chance that we'd end up with something as extreme or more extreme as what the sample got. So here, if the null hypothesis were true, so if, and now I could write down I can copy and paste. That's what I like about computers. And change a little bit. So if the population proportion of all Americans this year who are satisfied with the way things are going in the United States is not greater than, but the same as, or is equal to, the population proportion of all Americans last year who were satisfied with the way things are going in the United States. And if we conducted another study of 1,013 Americans this year and 1,011 last year. And just a note, by the way, this is all in theory. To really do it, you'd have to time travel, and that's probably not very easy. Good luck going to last year and asking. But you could do it in theory, at least. So if we conduct another study of 1,013 Americans this year and 1,011 last year, then there would be a And the p-value was 0.04, or how about 4% chance that the population, the sample of this year's Americans would have a proportion 3% higher than the sample from last year. How'd I get that 3%? Yeah, the 3% is the difference. If I take 19% minus 16%, I get 3%. Nothing hard, but you have to be able to do the simple calculation. Yeah, it's always easier to watch me do it than to do it yourself, right? Kind of how it works. Okay, now to interpret the level of significance, and same idea as chapter 9, what I can do is I can just copy and paste all the way up to just before the p-value of 4%. I'm going to copy, I'm going to paste, and say the population proportion of all Americans this year is satisfied with the way things are going in the US is equal to the population proportion of all Americans last year who were satisfied with the way things were going in the US. And if we conduct another study of 1,013 Americans this year and 1,011 last year, then there would be we're using a 5% level in significance, so 5% chance that we would end up falsely concluding basically what we concluded in the conclusion. So I'm just going to copy and paste that. So it ended up falsely concluding that the population proportion of all Americans this year is satisfied with the way things are going in the US is greater than the population proportion of all Americans last year who are satisfied with the way things were going in the US. Okay, so it's a lot of writing, but the good news is I copy and paste. And there's an online class, so you're welcome to copy and paste too. As long as you understand what you're supposed to copy and paste. Any questions at all on this hypothesis test? Okay, and hopefully you see it's not that different from last week. Now we're just comparing two things instead of comparing one thing with a number. Okay, the confidence interval. Let's go back to the calculator because I don't remember it. The lower bound is negative 0.0038. The upper bound is positive 0.0623. So negative 0.0038. What's from one? To 0.0623. That's what the calculator gave us. Okay, so notice it's, that's it. Notice one's negative, one's positive. So as a confidence interval, actually it doesn't show there's a difference. But in the hypothesis test, it does. So be real careful. And that has to do with two tail versus one tail, it turns out. So who remembers the first word to interpret a confidence interval that we had last week? Yeah, with. It's very helpful because it'll get you started. With 95% confidence. The proportion, population, proportion of all Americans. In fact, I can write this out, of all Americans this year who are satisfied with the way things are going in the United States. Is no more than it's when you're doing kind of interpretation, it's better not to use negative numbers. So it's no more than, I'm going to go 0.38% less than, and then it's the population proportion of all Americans last year who were satisfied with the way things were going in the United States. And no more than, and now we're looking at 6.23% more than. The population proportion of all Americans last year who were satisfied with the way things are going in the US. So when you have a negative and a positive, it's kind of, you just got to remember that one, the negative means that it's less than, positive means it's more than. Okay. Any questions on this? Any questions? All right, so I'm going to move on with another example. It's going to be different. Here's the question. Do single women spend more time cooking than single men? What do you think? What's your best guess? Okay, so you think maybe yes? Okay, so what we can say is the 35 single women who were surveyed averaged 58 minutes a day cooking, and their standard deviation was 12 minutes. The 38 single men who were surveyed averaged 46 minutes a day cooking, and their standard deviation was 16 minutes. Okay, by the way, I just want to let you know, as a heads up, I totally made these numbers up, but you can imagine running a survey, can you? Okay, and in fact, you know, I mean, you're not supposed to do what my example, but this could actually work for the project too, it turns out. Okay. What can be concluded at the 5% level of significance? Also interpret the 95% confidence interval. So one thing to note is that if you look at the 35 women and the 38 men, the first woman and the first man, they're not like together or anything. It's just a bunch of women and a bunch of men. Does that make sense? They're independent of each other. So this is independent data, and that's really important. So now let me go through and talk about how to do all this. Now we're going to be looking at H naught, the null hypothesis, and that's mu sub W equals mu sub M. So the population mean amount of minutes a day cooking for women is equal to the population mean amount of minutes a day for men cooking. Any questions on that? Okay, H1 is mu sub W is greater than mu sub N because we want to find out if women spend more time cooking. Any questions about this so far? Notice it's a mu, it's not a P, because the survey question that you're going to ask this First, these women are, how much time did you spend cooking today? And same thing with the men. How much time did you spend cooking today? And they're going to answer, I spent, 58 minutes cooking. Any questions on that? It's a number. So now we need to find a p-value. So we have to go to calculator. So now let's go back to the calculator menu. What calculator do you think we need to use? I'll let you look through. Which calculator do we need to use? Yeah, this is calculator number 18. Okay, because we have two independent samples and we have statistics. We don't have data here. We have statistics. We're given a mean and a standard deviation. We're not given the data. Any questions on that? Okay, for the first sample, the sample size was, that would be the women for first. And for the women, the sample size was 35. And the sample mean was 58, and the standard deviation was 12. And for the second sample size, the sample size was 38. The sample mean was 46. Standard deviation was 16. Any questions so far? Notice our H1 had a greater than, and we want a 95% confidence interval. So I'm going to use greater than, and CL will be 0.95. Any questions at all on entering it into the calculator? All right, then I hit calculate. A couple things. One is, do you think the sample sizes were big enough to be able to use the to be able to do this test? Yeah, so here, kind of like with proportions, with means, you remembered you had to have over 30. But when you have two samples, you have to have each of them over 30. So 35 is more than 30, and 38 is more than 30. You have to have each of them more than 30. So if you asked 500 men and 20 women, that would not be good enough. Not the total. It's each individual has to be over 30, each of the two groups. T, so it's a student's t-test, just like we had in chapters 8 and 9, will be 3.6428, etc. The p value, 0.00026. Any questions on that? All right, with that p-value, what can we say? What can we say? Yeah, there's statistically significant evidence, and also if the p-value is less than 1%, you can actually say there's strong statistically significant evidence. But you only use strong if it's less than 1%. Don't use strong if it's, say, 3%. So here's the conclusion. There is strong statistically significant evidence to conclude that the population mean cooking time for single women is greater than the population mean cooking time for single men. Any questions on how that conclusion was written? Any questions? All right, then we want the confidence interval. The confidence interval had lower bound, maybe I'll do 1 decimal, 5.4, because no one really cares that much about, a tenth of a minute, or definitely not 100th of a minute on who's more. So maybe 5.4 minutes to 18.6 minutes. Okay, actually, let's go to the nearest minute. That's even better. That would be 5 to 19. So our confidence interval will be 5 to 19. So to interpret the confidence interval, hopefully we're used to this, is with 95% confidence, the population mean time single women spend cooking is between 5 minutes and 19 minutes longer than the population mean time men spend cooking. Any questions on this confidence interval interpretation? Let me highlight population because, again, you got to have those words. You got to refer to the population when you're talking about the conclusion and the confidence interval interpretation. Any questions at all? Do you agree this is real similar to last week? Yeah, that's the good news. So if you understood last week, then this week shouldn't be too bad. If you didn't understand last week, then you got another week chance to try and learn it again, because this is really important. Okay, so the next example is one of my favorites of all. And when I explain why, you'll see. So one of the things that I use statistics for, besides teaching, of course, is making money in the stock market. Any of you have owned stock before or bought stock? Any of you bought or sold stock? Okay. I'm not seeing you all say yes. I'm seeing some no's. So let you know that I've actually been doing this for a very long time. Okay. Even when I was like really poor, I spend like just a little tiny bit to invest just so I could like feel comfortable about winning money. And I'll tell you, statistics helps a lot. So if you want to make some money in the stock market, stats helps a lot. And what I look for, if I can find it, and it doesn't happen that often, but I look for patterns that other people don't see. And if I can find patterns that other people don't find, then I can make a lot of money. And one of my favorite things is I actually took a course at UC San Diego when I was an undergraduate. And it was a sociology and political science course. And we learned how to take politicians, and hear their speeches, and then try to figure out what they're really talking about and what's really going to happen. It was a really great class. So I use that in combination with statistics to make money in the market. So I look for overreactions or underreactions to politicians' speeches. Okay. So one thing I'll never do is tell you who to vote for, or, I'm not going to tell you, Republican or Democrat, whatever, but I will tell you statistics. And that was something that happened. It was about 4 years ago, maybe or so. Who was our president 4 years ago? Yeah, Donald Trump. And again, I'm not going to tell you like or don't like, but I'm going to tell you how to make money. Okay. And that is, I was able to find a pattern. And something, if you remember, that Trump used to like tweet And he would tweet just things that he was going to go after China. I don't know if you remember that, but he used to do that pretty often. And what I noticed is when he tweeted about China, about going after them, the stock market went down. So what I wanted to do is I wanted to find a particular stock where I knew it was just I knew that it, at least on average, went down and then went back up maybe a week later. So then I went and I looked at stocks. One nice thing is that's data you can easily find online, what the stock prices were on any day you want to look at. And I looked at stocks and I found a pattern. And the stock I found was NVIDIA. You may or may not have heard of that company. Who's heard of that company, NVIDIA? Sounds familiar? You have? Yeah, they make chips. And by the way, not the kind of chips you eat, computer chips. And they also do they program into the chips artificial intelligence now. At the time, they weren't doing much AI, but they were doing a lot of programming. And what I noticed is that their stock was highly reactive to the tweet. So then I grabbed data. This is one of those, there was no way I can get a large enough sample size. How come? Why couldn't I get more than 30? This is one of the rare cases where you just have to go for it. Yeah, it's not like, there were, over 30 tweets about China in the last year, but there were a group, about 6, not a huge sample size, but it was good enough for me at the time. And what I did is I went and looked at the stock price of NVIDIA on tweet day and 1 week later after that tweet. Any questions on that idea? So on that first tweet, NVIDIA was going for it went down to $106. And then a week later, it went up to 113. Week 2, it went down to 110. Week later, it went up to 124. And we can see that each week, things were happening. So here's the thing. First thing, and I'm hoping this is obvious to you all, this is not about proportions, this is about means. Is that clear? If you look at the data, they're all numbers. That should be really obvious. Okay, now here's something that's new, and that is this is dependent data, because this 106 is paired with the 113. Because if you're buying and selling stock, you buy at 106 and you sell at 113. You don't get to buy at 106 and then sell at 127 and the next time buy at 102 and maybe 122 and sell at 113. It doesn't work that way. These are paired data. Do you see that? It's the tweet and a week later, tweet and a week later. So these are paired numbers. And because of that, we have paired data. And what we're going to do is we're going to look at the mean difference. The mean difference. And the way I'm going to write that is mu for population mean, sub d for difference. And H naught is that mu sub d equals 0. So the idea is if I was completely wrong and the tweet had nothing to do with the price of the stock, then there shouldn't be a mean difference, right? It should just be 0. Do you see that? H1 is mu sub d is less than 0, because if it went up, that means the first minus the second is negative. Any questions on coming up with H naught and H1? Okay, so H1, I think the easiest way of doing it is subtract. You take 106 and subtract 113, you get a negative number. Do you see that? And again, if I was right, then you should get a negative number because tweet day minus a week later should be negative. And that's what's going on. Okay, so H1 is mu sub D is less than 0. And I'm defining mu sub D is tweet day's stock price minus 1 week later stock price. Do you see how that works? And the p-value. So we need to go to a calculator. Let's go back to the calculator menu. Which calculator should I use? Okay, so the samples are not independent. So it's not two independent samples with data because these are dependent. This is two dependent samples with data, or number 20. Is that clear? Because when it's paired, it's dependent. So then it asks for data 1, data 2 separated by commas. And I can go and I can copy. And then I can paste. And when you do it from a table, it doesn't put the commas in, so I got to put commas in. Comma, 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 comma. And then I do the same thing with the second row. Copy and paste. And comma, 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 comma. So now we have all the data from data 1 and data 2 separated by commas written in. The alternative hypothesis, H1, is mu sub D is less than 0. So I do want this less than 0. This is one of those, I'm going to go for a 90%. Why do you think I'm okay with the 90% instead of a 95? Any thoughts? Yeah, it's not necessarily that it is kind of risky actually. It's a stock. This is money. There's some risk there. But here's the thing. If I can make money in the stock market 90% of the time that I invest and lose 10% of the time, have I done well? Yeah, yeah. In fact, maybe I'm not doing it for this class, but I might even go a little lower. But for this class, I said that we're going to stick with 90, 95, and 99. But I might go with, a little less, like 80%. But let's go 90% because that's for this class, that's what we're doing. Okay. Similarly, for the level of significance, 0.1 is what I'm going to go for because a type 1 error means that I thought I was going to make money and I ended up breaking even. Not great. I could have put it in the bank and made a little tiny. A type 2 error means that I ended up not investing when I could have made a lot of money. So to me, a type 2 error is actually much worse. So I'm going to go for the 90%. I'm going to go for a 0.1 for my level of significance. And I'm going to hit calculate. So a few things. This is a student's t-test. We need to assume a normal distribution, which is maybe not true, but it's the best we can do. Because we don't have a big enough, we definitely don't have big enough samples. So our t is negative 2.82. Our p-value is 0.018. Is that small enough to be able to reject the null hypothesis? What do you think? Do we reject the null hypothesis or do we fail to reject? I don't see y'all jumping in. P is 0.018. I said the level of significance is 10%. Because the type 2 error was worse than the type 1 error. Yeah, we definitely reject the null hypothesis here. So the p-value is 0.018. And we could say there is statistically significant evidence to conclude that the population mean price of NVIDIA is higher 1 week after the tweet than on the day of the tweet. So by the way, what do you think I did after I did this calculation? Any guess? Yeah, well, I'm not on Twitter, but I followed the news, which is good enough. And every time he tweeted, I bought, I waited a week and I sold. And you guess what happened? I made a lot of money. Yeah. So I think I put in around $5,000 and I made over $15,000, which is a lot of money for stock. And it was multiple times the tweets. And it works. Use statistics if you can. If you can find, statistics that helps you make money, go for it. There's definitely nothing illegal about that, by the way. Any questions on that idea? Okay, the conclusion, the confidence interval, by the way, I'm going to go 2 decimal places because we're talking dollars and cents. So it's negative 1342 to negative 224. So with 90% confidence, the population mean price of NVIDIA goes up by between $2.24 and $13.42 from tweet to 1 week later. Any questions on the confidence interval interpretation? Any questions? I do want to mention something. So why does the negative go away? And I always like to make the negative go away because it sounds better. It goes down by negative $2.24, by between negative $2.24 and negative $13.42. But that's kind of silly to say it goes down by a negative amount. Do you see that? And if you look at it, from $106 to $113, on that day, it went down negative $17 because we're doing first minus second. That's how the math works. But then the English, you want to kind of make it sound better, right? It doesn't make it a lie. It just is better vocabulary to explain what's going on. Do you see how that works? So that's how the negative goes away. Is that if you look, the average, the price definitely goes up. But if you take the subtraction, you get a negative number. So negative numbers means it goes up. I know that seems weird, but that's how it is for this example. Because it's first minus second. And if first minus second is negative, it meant the second was bigger. Okay. So notice that $2.24 between that and $13.42, that's real money that you care about. Does that make sense? Given that, it's not much more than 100%, $100, that means you're making, between 2% and say 12%. And that doesn't sound like that much, but it's 1 week. And if you can do that for 30 times in a year, that's a huge amount of money. Do you see how that works? Okay. And I've done this. I haven't done it since then, actually, but I've done it from time to time. I find a pattern using statistics, and then I take that pattern and then I invest, and it goes until that pattern doesn't work anymore. Obviously, when did this pattern stop working? This should be really obvious that it doesn't work anymore. Yeah, Biden doesn't tweet. So with Biden, it doesn't work. So that was the end of that. So when we got our new president, that was the end of that. In fact, actually, towards the end, Trump stopped tweeting. I wasn't able to make money on him anymore. Okay. And again, I'm not telling you you're supposed to like or not like Trump. I'm just telling you how to make money. Whether you like the president or not, you can still make money. Okay. Any questions at all on this this example? So I just want to give a heads up. One of the toughest parts about this class actually is deciding what hypothesis test or what confidence interval to use. So one is you should know whether you should use a hypothesis or confidence interval. And another is you should know which type it is. So things that you should always pay attention to at this point, by the way. One is, what was the survey question? Right? So like this example, the survey question was, what was the stock price? And we could see 106 or 113, 110, 124. So those are numbers. So that means we're not talking proportions, we're talking means. And then you should think about how many groups or how many survey questions there were. And in this case, there were two groups. There was a tweet day group and the 1 week later group. If it's a mean and there's two groups, then you have to decide, are they paired, which means dependent, or are they not paired, which means independent? Just a note, by the way, on the calculator at the bottom, it gives us subtractions. And I did that so you can see that we start with two data sets, but then when you do the subtractions, you end up with one data set of subtractions. And that only works for dependent data. Okay, and then it turns out it does what we did in chapter 9 for this list. So that's kind of how it works. That's where the math is going in a way. Any questions on understanding what's happening with hypothesis test for a difference? Okay. By the way, there's two groups. Do you think it could be done with more than two groups? Do you think you could do a hypothesis test with more than two groups? Say 3 groups? Let me answer the question first, and then I'll answer your question. Okay, the answer is no and yes. So the answer is, in our class, we're not going to go beyond 2 groups for quantitative data. But if you want to learn how to do it with more than 2 groups, then you need to go to a university where they teach upper division, stuff, and then you teach a higher level stats class. So it can be done, it just can't be done in our class because we can only do so much in our class. Okay. For proportions, it turns out that we will talk about for more than 2 in different ways, and you'll see how that works. Okay, so then the question is there a good way to remember the difference in the dependent or independent? So I like to remember that you think about pairing. The 106 and 113, these are paired together. Do you see that? The 110 and 124, those are paired. If I switch these two numbers and made the first 110 and a second 106, I've kind of violated what the data is doing. Do you see how that would violate it? Because you're buying at 106 and you're selling at 113. You're buying at 122 and you're selling at 118. You can't buy at 122 and then sell at 113. That wouldn't be possible. Do you see that? So these are paired numbers. And if they're paired, then it's dependent. Does that make sense? Another very common dependent data is when you ask a bunch of people 2 questions and you want to look to see if there's a difference between the answers. So let's say you asked, I don't know, how many calories did you eat for breakfast? And how many calories did you eat for lunch? And let's say you asked 40 people those 2 questions. Then do you see that why that would be paired? Because each person has 2 answers. Okay. So in a way, instead of people having 2 answers in this example, it's each tweet has 2 answers. You see how that works? So sometimes it'll be each tweet, sometimes it'll be each person, sometimes it'll be each location. So if each of something has 2 answers, it's paired. And that's kind of how you do it. Any questions? So it's a really good question. And again, it's one of the biggest, I told you, it's the biggest challenge, the hardest part about this whole thing is to figure out which calculator to use. Okay, is it 1 sample? Is it 2 sample? Is it paired? Is it dependent? Is it independent? Is it proportion? Right? Is it means? And then, by the way, next week we're going to have, is it about distributions? And again, we'll see where that comes from later, and we'll get there. Okay, so there's all kinds of things we'll be doing. Any more questions? All right, so what I want to do now is give you the secret word. And we're not done yet, but the secret word for this webinar is difference, because the chapter 10 is all about a difference between 2 variables, a difference between 2 means, or a difference between 2 proportions. So that was the secret word. Write it down. Here it is. And now what I want to do is talk about the projects. Okay, I talked last week. I already mentioned, I'll just quickly talk about what I said last week, and that is groups, still going to have groups. Hopefully you have groups by now. I see some of you have already posted on the Project 2 discussion board. But this project is going to be a lot different than Project 1. Okay. Some things are the same. The fact that you're doing it in groups, that's the same. You can do 2 or 3 people. 3 is easier because that means you only have 1/3 of the work to do. And also, if someone drops out, you don't start crying because you still have another person to work with. You don't have to work with the same partner. You can work with a different partner, but you got to have partners. Okay. Same thing about sending me a draft ahead of time. I do want to give you a heads up, and I apologize for this in advance, and I'll let you know again, is the project is due that is here. The project is due on December 10th. And I will let you know I will be mostly offline on December 8th, 9th, and 10th. So if you wait till towards the end, I'm not going to be able to help you. And it's not because I want to be mean to you, but there's a conference and I'm on the conference committee to, it's a math conference, and I am helping to organize the conference. I'm also a speaker of the conference. Okay, so I'm actually, this might be interesting to you. I'm actually talking about a project that has been worked on in the state of California, and I'm one of the organizers of this thing. And that is to, one piece of it is to collaborate and help collaboration between the community colleges, the Cal State universities, and the University of California universities. And it's all OER, free materials. So I'm giving a talk on that, okay, with a couple other people, one from Cal State, one from UC. The 3 of us are co-presenting. The other thing I'm doing, which has a little math in it, is we're doing what's called an estimation run. So you're used to like maybe racing and, whoever goes fastest wins. But this is a math estimation run. It's not who goes fastest wins. You have to predict how long it's going to take you to run that pi miles, 3.14 miles. And whoever gets the best prediction wins. Okay. And if you're really good with statistics, you might be able to figure out how long it's going to take you if you practice a bunch of times. Okay. But again, you probably won't be doing it. It's in Monterey. But the point is that during the project, when it's due that weekend, I will not, I might have a few minutes in the early morning to check my email, but that's about it. So I want to give you a heads up that if you wait till the end, I can't help you. I'm sorry about that. Okay. I will be checking on Thursday and Wednesday and Tuesday, beforehand to help you out, and that Monday. So that's just a big note in terms of my calendar. Okay, so then if we go to project 2, and again, this is on Canvas. You have this ability to click on this, so you can do this too. But I want to go through it so that if you have questions as we read it, I can help you out, and I can maybe, elaborate on anything you might not be able to understand. So the purpose of project 2 is to use confidence intervals and hypothesis testing to support or show lack of support for a research project. So I want to give a big heads up. This is not project 1. The main focus of project 1 was your sampling technique and the mean and standard deviation and quartiles and, and all the statistics you got and charts and analyzing charts. This is very different. This is confidence interval and hypothesis test, and that should be the main focus. Okay. All right. Similar to before, you must first decide what you're interested in researching. That makes sense. And then design your study and collect your data. So what you should, once you have your partners, at that point, what you should do is decide what your null and alternative hypotheses should be, because that's what you want to research. And you should write them down. And also decide, which I'll talk about in a minute, but you should also have a client. Just like before, you're going to be doing this for a client. And then you should think about how to collect data. What should you do as soon as you come up with that? Any thoughts? Yeah, post your hypothesis. Okay, I would say in symbols and words on the project 2 discussion board. And then I can look at it and let you know if it's going to work or if it's not going to work. Okay. Any questions on that? That's your first step. Your next step is to collect your data. Okay. And you should, in your project, describe the sampling technique. You don't need to spend a lot of time on it. And notice that any technique may be used. What's the easiest technique to use, by the way? Yeah, convenience sampling. Okay, you don't have to use convenience sampling, but hey, you don't get taken. I don't take points off if you use convenience sampling as long as you say you did. Do you see that? Okay, so you write down how you collect your data. Convenience sampling is fine. Okay. This is different than project 1. In project 1, it had to be a survey of people. Project 2 does not have to be a survey of people. Okay, for example, and don't do this exact one, but you could collect data if you can look for maybe a pattern that might have happened in the stock market. Do you see that? And you can look at maybe 31 different things. Okay, you have to have over 30, because if you don't, then hopefully you know by now that you can't really do any good statistics. Okay. So you should either be doing a difference between 2 independent means or a difference between 2 dependent means. Your data needs to be numbers and not yeses and nos. Any any wonder why for this project I'm telling you not to do a yes/no survey? There's a reason. And it's something that we talked about last week. You remember? Maybe you don't. If you're going to do a yes/no survey project, the problem with it is to have data that has a small enough margin of error to be interesting. Do you remember how big a sample size you typically need to have for good data? Not for using the normal distribution, but for good data. And you remember? Yeah, over 1,000. And I try not to be evil because to make you do over 1,000 data values, good luck. So that's why I'm telling you, if you have 40 or so or 35 for a quantitative study, that's usually fine. Okay, it's usually you usually get a good margin of error, but you have to have in the several hundreds, maybe thousands, to have good data for a confidence interval and hypothesis test. So don't even think about it. It's just way too much work. So make it for means. Got it? Same rule, by the way. You are not who are you not allowed to ask if you do a survey of people? Yeah, children. Yeah, under 18. Okay. The only under 18 allowed to ask are college students at your college. But basically, you're not allowed to go to a high school or a middle school and ask. Okay. Actually had that happen in Project One. It's like I thought I yelled and yelled about it, but maybe not loud enough. So I'm yelling more. I don't want to get sued. You don't want to get sued. It is against the law to ask children without all kinds of legal permissions from parents and all kinds of stuff. And we will not go there. So adults are fine. Okay. Just note though, you don't even have to ask people. Like I said, in the stock market example, that was just grabbing data. Do you see that? It is important that if you could grab the entire population and do a census without too much strain, then this project won't work. So the population needs to be very large. Does that make sense? Because there's no reason to do a confidence interval and hypothesis test if you could just get the entire population. Because then you could be 100% certain with 0% chance of an error. Do you see? All right, so you're going to be doing a list of the summary statistics, only the important ones. The most important are the means. Those are important. The other is going to be the standard error. Do you remember what the standard error was? What chapter did we talk about that? Do you remember? That was chapter 7. That was chapter 7. We talked about the standard error. Okay. It turns out for 2 samples, the formula is more complicated, but that square root of the sample size as an idea still kind of works. Does that make sense? So if you want a margin of error that's, say, half the size as what you got, but you want the same confidence level, then you're going to have, let's say you started with a sample size of 40. How big a sample size would you need to get? If you start with 40, how big would you need to get if you wanted half the margin of error? How big? 80 is a good guess, but it's not right because I told you square root of n was in that standard error. So it's actually 160. You need to multiply by 4 because the square root of 4 is 2. And there's a good chance that kind of thing is going to come up in your project, because you're going to have to decide in a future study, how big a sample size would you need? And that's the kind of calculation you'd have to do. Just a note, I'm not going to play it, but I made a video on the standard error because a lot of people forget about it. And so I made a short video just on that. And just a note, you're going to be using the spreadsheet, the same spreadsheet. So in particular, if you remember, this was a spreadsheet. And the good news is you made a copy for project 1, and you can use the same copy for project 2. You don't have to make a new copy. What you do have to do is look towards the bottom, and you'll see we're not doing 1 var stats. What are we doing now for this project? Yeah, 2 var stats. So you click 2 var stats. And now you'll see there's a first and a second. And the first thing you have to do is highlight this, hit the backspace, and that'll erase all the numbers that were there, and then put your data in. And then instead of like clicking on the right calculator, you have to move your eyeballs in the right place. So either you're going to be doing independent or you've been doing dependent. Okay. And by the way, you have to know which one you're doing. Depends on what your project is. And then make sure that if you're doing dependent, then you copy and paste the columns N and O into your paper. If you're doing independent, you copy and paste the columns J and K into your paper. Any questions on that? That must be done. You have to copy and paste it in. Is that clear? Okay. And notice the standard error is given. It's calculated for you. You don't do any calculations. It's there for you. Okay. If you really want to see it, you can read this code and see what I coded in, but that's the standard error. Okay. You're going to have to decide on the confidence level. Notice, let's say you're doing dependent data. Then it's really easy. You can change that 90 to say 95. And then it changes. Do you see that? So it's very easy to change the confidence level, 90, 95, 99. You just type those numbers in. Okay, and unlike the other calculator made, this one you actually type 95, not 0.95. That's just a note. So it's a percent level of confidence, not the decimal level. Any questions on using the spreadsheet? Okay, so then let's go back. Okay, so you should talk about the confidence interval. You should state the pros and cons after looking at the 90, 95, and 99. And for your client, which of the 3 is the best based on the pros and cons? Okay, and what decisions will the client make based on the lower bound of the confidence interval and based on the upper bound of the confidence interval? Okay, just like project 1, throughout the whole paper, you're going to be talking about the decisions the client will make. Okay, any questions on that? All right, then you do a hypothesis test. And again, very simple. What you have to do is be able to read. So for example, let's suppose you were doing independent. You should know whether you're doing two-tailed, right-tailed, or left-tailed. And you just read the right p-value depending on what you're doing. Do you see? Okay, so again, p-value will be shown. You have a test statistic. And your hypothesis for the difference will probably be 0. Almost all the time, that's what you're going to be using. Okay, so you should do things in the order at which I said always happens. Remember, the first thing is you write down your null and alternative hypothesis. The next thing, what comes after that? What comes right after writing the null and alternative hypotheses down? No, before you collect your data, you're not ready to collect your data. You remember? You look at the repercussions of a type 1 and type 2 error. And then based on the repercussions of a type 1 and type 2 error, you decide on the level of significance, being 0.01, 0.05, or 0.1. Do you remember doing that in chapter 9? Chapter 10 doesn't change, by the way. It's the same idea. Okay, so that's the next thing you do. Then, after you've decided the level of significance, then you collect your data. Okay, and all this should be done in your paper in that order too. Then after you collect your data, you look at your spreadsheet, you put it in your spreadsheet, and then you start making these interpretations. Okay, then you look at the p-value and then decide whether to reject or fail to reject the null hypothesis. And then you talk about how your client is going to use that information. Talk about how the client is going to use the p-value. Talk about how the client is going to interpret or use the level of significance. And then after looking at the p-value, decide if it's time, if it's a good idea to have a new study with a bigger sample size. All right, let's suppose that your level of significance was 5% and your p-value is 0.04. Do you think you'd want a new study? Think you'd want to do another study with a bigger sample size? See, yes and no. Okay, so I like, my favorite example is soccer. Imagine you're the coach of the soccer team, and your team is winning 5-4. There's 3 seconds left in the game, and your team player is about to kick the goal, and you think that I kick the ball, hopefully into the goal, and the other team fouls your player, but the referee doesn't see it and doesn't cause a foul. Should you argue? What do you think? Should you tell the referee to go look at the video and, and check it out and see the foul? Okay, the answer is no. There's 3 seconds left in the game. You're ahead 5-4. Why argue? You're winning the game. Do you see that? Okay, there's no reason to argue. So if your level of significance is lower, if your p-value is lower than level of significance, there's no reason to do another study with a bigger sample size. You won. Why waste your time? Do you see that? Let's say you were, testing a drug for, you're the pharmaceutical company and you want to see if your drug works. Well, if you got a p-value that's small enough, your drug works. Time to tell the FDA, approve it, and go sell it. Do you see? You don't need to do another study. Does that make sense? Okay, on the other hand, let's say the p-value is 0.06 and your level of significance is 0.05. Then should you conduct a study with a bigger sample size? Okay, then it's yes. And now kind of the soccer game is now you're behind 6-5. And the same idea, your player is about to kick the ball and you think they might make a goal, and the other team fouls your player and the referee doesn't see it. Then, yes, it's a good idea to say it's time to relook at it. Do you see? Because now you've lost the game unless you can do something about it. Do you see that? Okay, so then you would actually get you have to use a bigger sample size. If you use the same sample size over and over again, you're eventually going to get a type 1 error if you were wrong in the first place. Do you see? So that's why the bigger sample size. What if the p-value was, say, 0.89? Do you think it's a good idea to redo it with a bigger sample size? What do you think? If the p-value is 0.89. Okay, so let me give you the soccer analogy, but now I'm going to give you the real one. I don't know if any of you saw our women's soccer game that was on Friday. Any of you see it? I was there, but I don't recognize all your faces, but I was there watching it. Okay, so in that game, the score was 12-0. Our team was winning. Okay, now let's pretend it didn't really happen. Let's pretend that our player was about to kick the ball. Let's say not our player, let's say the other team's player was about to kick the ball and the coach thought they were going to get a goal. There was 3 seconds left. Should that coach argue? What do you think? Okay, definitely not. There's no, you lost the game. Do you see that? You might get one more score, but then it's 12-1. You're not going to win with 3 seconds left. Do you see that? So similarly, if the p-value was 0.89, you've lost. It's hopeless. It's not worth getting a bigger sample size because it's time to give up. Do you see that? Any questions on that idea? Because you're so far away from 5% that it's hopeless. Okay, so that's just something you should be doing towards the end of your project. It's talking about that. Okay. Also, maybe towards the end, you should talk about what assumptions did you make? By the way, if you think you have to make an assumption that you have a normal distribution, then your sample size was too small and you're not allowed to do that. So the normal distribution should not be one of the assumptions because your sample size has to be bigger than 30. What assumptions might you have to make? What assumptions are pretty likely? Here's the hint. Most of you are going to do convenience sampling. But what assumption might you have to make? Yeah, data is accurate. I think better is representative of the population or unbiased. So there's no bias in the data. And it might be a bad assumption, but at least you can call it an assumption. Remember the first 3 letters of assumption. Never a good thing, but sometimes you have to make it. Any questions on that? Okay. And then at the end, talk about how further studies might be done, delve deeper. Don't write a whole page of that. That's like a sentence or 2. Most of this project is on the confidence interval and the hypothesis test. Another thing that a lot of people make mistakes on, you shouldn't have the confidence interval and hypothesis test in the same paragraph. They should be completely separate pieces. Does that make sense? It's pages on each, but don't put them together. And do not say because you used a level of significance of 5% that you're going to use a confidence level of 95%. Those do not go together. Any questions at all about the project? I do want to remind you that you are always welcome and encouraged to post on the Project 2 discussion board. You're also welcome to chat with me in office hours. You're welcome to work with the tutor. Okay, like Kyle is our embedded tutor and he can definitely help you out. So, don't just assume that you're by yourself. Okay, you can actually get help and I want to help you. There's no, even the last one I didn't have a limit on pages. There's no limit on pages, but if you think you can write this project in 2 pages, think again. I don't tell you how many pages, but there's a lot of stuff to write. Often this has fewer pages because there's no charts, and charts often take a whole page. Does that make sense? It's kind of similar in pages of writing, but not similar in pages. Yeah, no charts or graphs. Just those, 2 columns. It might be J and K, it might be N and O, depending on your project. So that's about 7:31. My goal is always around 7:30, and I made it. So that's about all I have to say in terms of the project and chapter 10. But I'm always around to help you out. Oh, one more quick thing is that this Friday, there's no office hours. Anyone know why? Yeah, it's a holiday. So we should be having a holiday. Enjoy it. It's Veterans Day, and let's honor our veterans. So it's Veterans Day, so I don't have office hours. I'm not in my office here. I'm not online. I'm going to be actually driving down to a wedding. So I'm not going to be in office hours on Friday. But up till Thursday I will, back Monday I will, but not Friday. Okay, so why don't I stop the recording?